Ok. Amigos, hoy nos vamos a aventar un set cortito de 3 horas y media. Para los que gustan acompañarnos aquí en live en YouTube. Adiós. Amigos, hoy nos vamos a aventar un set cortito de 3 horas y media. Hola, ¿cómo estás, mi man? Vamos por ahorita que lleguen más personas. Adiós. Y voy por café, de hecho. Vamos a empezar en 4 minutos más, pero voy por café. Hola, Diana. Hola, Kate. Hola, Emilio. Ahorita vamos a empezar a estudiar, Nomás estoy esperando a que se esté listo mi café para ir a prepararlo. Vayan por café y todos, listos con sus apuntes y demás. Amigos, hoy nos vamos a aventar un set cortito de 3 horas y media, para los que gustan acompañarnos aquí en live en YouTube. Adiós. Yo también soy tu fan, Diana. Amigos, hoy nos vamos a aventar un set cortito de 3 horas y media, para los que gustan acompañarnos aquí en live en YouTube. Bien, ya está anunciado ahora sí en YouTube. Digo, en Instagram. Ahí está. Ya subí la historia, voy por mi café, ahí regreso.
¿Ahí tienes tu cartera?
Mi cartera está arriba.
Ahí tienes tu tarjeta de
Okay.
banco. De
Sí. Ok. A ver. Ok, amigos. Ok, pues ya saben, la dinámica es la misma. Otra vez, ¿cómo lo vamos a hacer? Otra vez vamos a estudiarnos un set de 3.5 horas. 3 horas y media. Hoy nos vamos a ir un poquito más leve porque, pues, tengo sueño y por eso empezamos un poquito más tarde también. Vamos a hacer, son 7 sets. 7, hola Luis, sets de Pomodoro. 7 sets de Pomodoro, son 25 minutos de trabajo, alternando con 5 minutos de descanso. Comenzaremos en 2 minutos, vamos a aventarnos el primer set, ¿sale? Ahí están las instrucciones generales, recuerden que pueden dejar preguntas si gustan, se responden en los 5 minutos de descanso. Así que ahí está Dieguito, mi hermanito, si lo quieren saludar. ¿Qué, amigos? Yo la última media hora lo voy a dedicar a leer de manera recreativa, pero ahorita pues solamente vamos a estudiar, ¿verdad? Porque pues me siento medio tonto siempre que veo algo nuevo de matemáticas y no sé nada.
¿Ya saben qué onda con las sumas?
Queda un minutito, ¿ok? En un minuto comenzamos, amigos de mi vida. Amigos, hoy nos vamos a aventar un set cortito de 3 horas y media, para los que gustan acompañarnos aquí en live. Ya voy. Adiós. Prepárense, ¿eh? Let's get it. Muy bien. Café listo. Yo no estoy tanto. Let's go. Sí, Kevin, a mí también me gusta mucho estudiar así. Como que ya no me siento tan solo. Como que nos acompañamos en soledad, ¿no? Ahí está, güey. Nada, está enfrente. Ok, amigos, entonces ya son oficialmente las 5 de la tarde y vamos a comenzar. Entonces vamos a poner la alarma, ¿verdad? Son las 5 de la tarde aquí en Tijuana. Ya en horas centro es un poquito más tarde quizás. Yo estoy a esta hora porque a esta hora me siento ahorita a gusto. Vamos a ponerle 5:25. Listo. Let's go. Ok, amigos. Entonces vamos a empezarle. Venga. what we're going to have here, we just have 3 introductory videos just to give you kind of just the question so that you can get started on your own practice. So if you see the question, you'll have a basic idea of what the format is about at least. At the end of the math module, after all the other lessons, then we'll have a section advanced QC strategies. And there we'll talk about how the different content areas are tested in the QC questions. How do the content comparison tests be done? So, what are these questions about? Content comparison questions. This question format will present entries in 2 different columns, labeled quantity A, quantity B. A column will either be a number or something that could take a numerical variable or from formulation. X might be the area of the triangle, might be the number of employees. Obviously, it's a word from thing you have to have context for that as part of the question. Our job is to compare these 2 quantities, try to figure out which one is bigger. That's the big idea. Answer choice B means quantity B is greater. Answer choice C means the 2 quantities split into it because every single quantity means anything other than greater than quantity A. C means that at all times, in all ways, for all possible values of a relevant variable, the 2 quantities are always equal. In other words, A, B, and C implicitly have the word always. Greater than shows up sometimes, less than shows up sometimes, equal shows up sometimes. If then you would actually see on the GRE, I'm keeping the math relatively simple because I'm more important in just stressing how the question type works rather than going into detail about mathematical ideas. So here we have a comparison. We have to compare 8 to the fraction 53/7. Well, of course, the easiest way to compare 2 things is put them in the same form. In other words, we can write 8 as 56/7. Well, 56/7 is bigger than 53/7. So right away, that means column A is bigger. Column A is bigger. The answer is A. That was a very straightforward question. Here's another question. Pause the video for a moment and then we'll talk about this. Okay. So, now we're given a geometric figure. So notice incidentally, this is standard for the quantitative comparison. Sometimes you're just given quantity A and quantity B, nothing else. Sometimes you're given text about the problem, or you're given a diagram or some kind of thing. Whatever appears above the question is relevant to both quantities. So here we're told that A, B, C, D is a rectangle. And we Aunque los viernes la gente no estudia. Ok, amigos, llevamos media hora ahorita de estudio, muy buenos. Vamos por las 3 horas y media, solamente llevamos media hora. A ver, ¿qué preguntas tienen por acá? Me gusta estudiar así a mí también. Yo también los admiro, qué bueno que están por acá. Tienes examen media hora de clínicas, ya debería estar haciéndolo Diego. Doctor, lo admiro mucho por lo que ha logrado. Gracias, qué bueno que te han servido los videos, me da mucho gusto. Edson pregunta, hola, ¿cuánto tiempo de anticipación me recomiendan para empezar a estudiar para mis exámenes de primero de medicina? Pues tienes que estudiar diario, o sea, la verdad es que es mucho contenido, te vas a dar cuenta que mientras más te esperes, más se te van a juntar el contenido. No quieres que se te junte el contenido porque si no es muy complicado estudiarlo todo de golpe. Yo normalmente recomiendo que estudien diario y que el último día pues se dediquen a repasar. No, yo no soy de los que tengan la idea de que se tienen que desvelar mucho. La verdad, yo contadas veces en la carrera me desvelé. Entonces, yo por eso, sí, no es preparatoria, ¿no? Entonces no trates de leer un libro un día antes, es imposible, no se puede. Entonces, estudia diario, estudia constantemente, que no se te junten los temas poco a poco y el último día, antes de tu examen, repasas si quieres. Pero ya no tienes que estudiar mucho, si es que estudiaste bien. ¿Qué libro de fisiología recomiendo? Mis libros de fisiología favoritos son Fisiología Médica de Guyton y El Linda Constanzo. ¿O no? Y Linda Constanzo. Ahí está. Hay otros. El más intenso que conozco es el Boron, está muy perro, pero está muy pesado. También no lo recomiendo para aprender a leer nada. Ese libro son los que te recomiendo. Hay más, está el Gannon, está el Bestie Taylor, está el Conti, hay muchos, pero los que más me gustan a mí son esos. Y sí, las flashcards, como recomienda Ricardo, es una buena idea, sobre todo cuando son temas de memorización como anatomía, microbiología o farma. Trate de que sus flashcards sean cortas, chiquitas y muy resumidas. Ok, amigos, nos quedan 3 minutos de descanso, así que aprovechen. ¡Tarán! Hola, Paloma, ¿volviste? No importa, yo tampoco escribo bonito, escribo también de la patada. Yo otra vez estoy estudiando para mi maestría. Quiero entrar a una maestría y por eso estoy estudiando, Diego. Regreso en 3 minutos, me voy a acostar al sofá.
¿Por qué dices que no estudian en bien?
¿Ah? Son 13. Diego. ¿Qué?
Vale.
¿No?
Voy a intentar hoy con la selección de los señores de no me deja mucho. Voy a comprar. ¿Usted tu peso para comprar el boleto de Gresham?
¿En qué?
¿Tu peso?
Sí. Nomás si luego me lo positas. Hola, ¿qué tal? ¿Qué estoy estudiando? Ya te comenté. No ve que tomas apuntes. ¿Tomas apuntes? Sí, solo que ahorita no lo estoy haciendo, pero sí tomo apuntes por lo regular. Muy bien, amigos. Vamos por la hora. Vamos a poner el alarma y comenzamos. Venga. Slightly less than 33 1/3% of slightly less than 6,000. And 33 1/3% is a third. So a third of 6,000 is 2,000. So it means that overall, whatever this answer is going to be, it's going to be something slightly less than 2,000. Now look at the other one. 41.6% of something a little over 5,000. So I'm going to write this again as something a little over 40% of something a little over 5,000. Well, 40% of 5,000 would be 2,000. And the answer would equal something slightly larger than 2,000. So again, I don't care about the exact value. All I care about is the comparison. Anyway, that both columns contain numbers, then I'll make the relationship pretty mathematic. In summary, the GRE does not care about the ability to calculation. You might estimate on more than half of the quantitative comparison. It's very rare to have a quantitative comparison question on which you have to do a precise calculation. Some of the tricks I mentioned, doing part-wise comparisons, that's a strategy that comes up. Matching operations. So to begin, I'll say, there's only so much about QCs we can discuss right now, because I realize you're at the beginning of the math module, and there's quite a bit of math that you haven't reviewed yet. So after the math content modules, we'll have a much deeper module called Advanced QC Strategy, in which we'll discuss how the different content areas show up. Dude, I'm talking to you. Have you know any cookie? It doesn't really make sense right now, for example, to talk about quantitative comparisons in geometry, because we haven't reviewed geometry yet. So all those videos are at the end of the math content modules. I'm going to die, so right now, I just want to give you one strategy that will be very helpful, because in your practice, you're going to start to encounter quantitative comparison questions, and I want you to at least have some strategies for attacking them. So I'm going to describe a quick trick that one can use in a wide variety of quantitative comparison questions. For now, I will call this trick matching operations.
you see, we're trying to determine the relationship between two quantities. We could say that between the two quantities, there's some unknown relationship. It might be always greater than, always less than, always equal, or it might be some combination or indeterminate. It's important to recognize there are mathematical steps we might take to simplify the problem that do not change this underlying relationship at all. We can add the same number to both quantities. We can add a positive or negative number to both quantities. We could subtract the same number from both quantities, or we could multiply or divide both quantities by the same positive number. Very important. Get multiply or divide. Right now, simply practice this as a strategy, because when you are used to thinking this way, this strategy can
I'm going to die.
many PhD problems. Here's a practice problem. Pause the video, and then we'll talk about this.
Or I shouldn't endlessly.
Okay. So, first of all, I realize that if you haven't reviewed fractions yet, it might be a little bit challenging to think about this. And so if you're rusty with fractions, don't worry, we have a whole module with fractions coming up soon. I'm just going to talk about some of the very basics here. Now, you may notice, for example, that 35 divided by 8, that's 4 and some kind of remainder. And 13 divided by 3, that's also 4 and some sort of remainder. In other words, 4 equals 32 divided by 8, or 12 divided by 3. So both of those are reasonably close to what we have here. So we can subtract 4 from both of these. And in each case, we're going to find the appropriate common denominator. So with the 8s, we're going to turn the 4 into 32 over 8. And with the thirds, we're going to turn it into 12 over 3. And then we have a common denominator, so we can subtract in the numerators, and we get 3/8 and 1/3. Well, we have a few different ways that we can approach this. One way is to find the common denominator of the two fractions now. So multiply the left one by 3 over 3, multiply the right one by 8 over 8. And we get 9/24 compared to 8/24. And so we see quantity A is bigger. Incidentally, when we got to 3/8 compared to 1/3, we also just could have cross multiplied. And then we get 9 on the left, 8 on the right. And again, we'd see quantity A is bigger. So it turns out, none of those steps change the relationship at all. And so, quantity A has to be bigger even than the original. Here's another practice problem. Pause the video and then we'll talk about this. Okay. This can be a tricky problem for a variety of reasons. This involves a little bit of algebra. And again, if you're rusty with algebra, don't worry. The algebra here is very simple. We have a couple modules coming up with a lot of x. Then we're going to go to comparing x to 3.5. So this is interesting. If x is bigger than 3, how does it compare to 3.5? Well, if you're stuck thinking about integers, so the answer is B. Quantities by the same positive number. These operate. basic real numbers. Let me begin by saying this video really starts at square one. It starts with the very basic properties of all mathematics. If you're reviewing math, this is a wonderful place to start. We'll cover everything from the basics. But if you're already familiar with math, and math is something you're really good at, then you probably don't need to watch all these introductory videos. What I strongly suggest is just skip ahead to the summary, read the summary. If there's something in the summary that makes absolutely no sense, then go back to the video and watch the video. But don't force yourself to watch the video if it's stuff that's going to be way too easy. Very important to know yourself and pace yourself in this process. For folks who really want to learn everything from the beginning onward, let's start at the beginning. When the test says number, it always means a real. By a real number. Well, a real number is any number on the number line. This includes round numbers as well as fractions and decimals. All the numbers pictured here, as well as all the numbers and all the spaces in between. Numbers like 1/3, or pi, or the square root of 7. All of these are numbers. They're all real numbers. When the test says number, this number could be any number on the number line. It could be positive, negative, or zero. It could be a whole number or a fraction or a decimal. This is one of the ways that the test loves to track, loves to begin a math problem. X is a number, and then it goes on, and people assume that since X is a number, it can only be 1, 2, 3, 4, 5. In other words, that it has to be a counting number. People forget about negatives, they forget about fractions and decimals. Very important not to fall into that trap. If you see the word number, you have to be thinking about all these categories altogether. We will discuss fractions and decimals in later videos. Right now, notice that 0 is the only number that is neither positive nor negative. So we have these two very large categories, positive and negative. 0 is the only number on the number line that doesn't fall into either one of those categories. One special type of number is the integer. Integers include all positive and negative whole numbers. If the question asks about integers, it could be any number in this set. It could be the positives or the negatives. If the question asks about positive integers, then that's ordinary counting numbers, 1, 2, 3, 4, 5, 6, etc. Very important to keep these three sets straight. Sometimes questions will ask about numbers, sometimes they'll ask about integers.
So is your communion?
No. Can you check, man?
No.
Ahí.
Está quedado porque están callados y luego de repente.
Integers, sometimes they'll ask about positive integers. Those are three different sets. It's very important not to confuse them. Back to all the real numbers. There are a few vocab words you need to know. These concern the four fundamental operations. You may want to pause the video here just to verify to yourself that you know these four terms. The result of addition is called a sum. The result of subtraction is called a difference. The result of multiplication is called a product. The result of division is called a quotient.
Oh.
These are four vocab words you need to know.
I don't know it. Deep dive.
Vamos con.
Entonces,
There are also some fundamental arithmetic properties common to all real numbers. To discuss these, I will use A, B, and C to represent real numbers. These are terms you don't need to know. You don't need to know the names of the properties. All you need to know are the properties themselves. The first one is the commutative property, the ability to switch the order. So, for example, we can switch the order of addition. A plus B equals B plus A. Doesn't matter which order we do it in, we get the same answer. Similarly, with multiplication, we can swap the order around. A times B equals B times A. Again, we can swap the order around, we get the same answer. Addition and multiplication are commutative. Division and subtraction in general are not commutative.
oh.
We swap the order around the subtraction, we get different answers. 7 minus 4 does not equal 4 minus 7. But keep this in mind, if we rewrite the subtraction as the addition of a negative, that's a very sophisticated move, then it would be commutative. So 7 minus 4, we can express that as 7 plus negative 4. And then we could swap the order, negative 4 plus 7. So we can actually perform that swap if we need it. So all of these are properties you need to know. You need to know what you can do with these numbers. But you don't need to remember the word commutative. That word will not be on the test. The second property is the associative property, the ability to group things. So if we're adding three numbers, we can group them. We can add B plus C first, or we can add A plus B first. Either way of grouping leads to the same answer. Here we can add the 3 and the 5 first, or we can add the 2 and the 3 first. Either way, we get the same answer. Similarly, with multiplication, we can group them B times C first, or A times B first. We multiply the 3 and the 5 first, or we multiply the 2 and the 3 first. Either way, we get the same answer. Addition and multiplication are associative. Subtraction and division in general are not associative. Again, you need to know what the numbers do. You don't need to know this word, associative. That's not a word the test will test you on. The distributive property. This one is a big one. First of all, multiplication distributes over addition, and it distributes over subtraction. That's the very weakness. Swap the order. A plus B equals. And multiplication are commutative, division and subtraction in general are not commutative. We swap the order around a subtraction, we get different answers. 7 minus 4 does not equal 4 minus 7. But keep this in mind, if we rewrite the subtraction as the addition of a negative, it's a very sophisticated move, then it would be commutative with these now P first, or we could add A plus B first. Either way of grouping leads to the same answer. Here we can add them. Three and the 5 first before we could add the 2 and three first. Either way, we get the same answer. Similarly, with multiplication, we can group them B times C first, or A times B first. We multiply the 3 and the 5 first, or we multiply the 2 and the 3 first. Either way, we get the same answer. Addition and multiplication are associative. Subtraction and division in general are not associative. Again, you need to know what the numbers do. You don't.
Multiplication.
Need to know this word associative. That's not a word that the test will test you on. The distributive property. This one is a big one. First of all, multiplication distributes over addition, and it distributes over subtraction. So we can do the addition or subtraction first, and then multiply, or the distribute.
Ok, amigos, ya llevamos a una hora. Llevamos una hora ahorita estudiando. Tenemos otra vez un descanso de 5 minutos. Continuamos ahorita en 5. Venga. Bueno, no hay muchos porque no hay que estudiar los viernes, pero we gotta do it. I don't even want to study. Pues somos 11. I don't like numbers that much. Uf. Hola amigos, vamos por el round de la hora y media, ¿sale? Venga. 3, 2, 1. Vámonos.
Hola, ¿cómo están?
Over addition, and it distributes over subtraction. So we could do the addition or subtraction first and then multiply, or we could multiply times each piece and then subtraction. So for example, we can add add 2 plus 3 first and then multiply, or we can do do 6 times 2, 6 times 3 first, and then add those two products separately. Either way, we get the same answer. Similarly, with subtraction, we can subtract the 3 and the 7 first, get the 4, multiply that by 12, or we could multiply the 12 times 7 and separately multiply the 12 times 3, and then subtract those two products. Either way, we get the same answer.
I made a mistake.
There are other properties
Good.
that concern
Take a look
the
at these.
special numbers 1 and 0. The first one is multiplying and dividing by 1. Very simple. We don't change a number when we multiply or divide by 1. represent that symbolically this way. A times 1 equals A, A divided by 1 equals A. Absolutely no change if we multiply or divide by 1. Multiplying by 0, anything number when we multiply or divide.
Entonces se dará media vuelta de corazón cuando muera la tarde.
Divide by 1. We can represent that symbolically this way. A times 1 equals 3. Example. We can add 2 plus 3 first and then multiply. Or we can do 6 times 2, 6 times 3 first, and then add those two products separately. Either way, we get the same answer. Similarly, with subtraction, we can subtract the 3 and the 7 first, 4, multiply that by 12. Or we could multiply, or we could use
What? Multiplying.
multiplying by 0. Anything times 0 equals 0. Again, very simple. So A times 0 equals 0 times A equals 0. So we're perfectly allowed to multiply by 0, and we always get 0. We're not allowed to divide by 0. That's a very important point. The zero product property. If the product of two numbers is 0, one of the factors must be 0. So if A times B equals 0, then A equals 0 or B equals 0. And notice that the word or there, that's an essential piece of mathematical equipment right there. That's actually part of the math. That's not decoration. That creates the logical connection between the two equations. The zero product property is very important in factoring and in solving quadratics. So you'll run into it there. Those are in the algebra module videos. Dividing a number by itself. When any non-zero number is divided by itself, the quotient has to equal 1. You can express this as A over A, or A divided by A equals 1. Very straightforward. So in summary, the test itself, when any non-zero number is divided by itself, the quotient has to equal
Biggie. Biggie's Smalls.
Okay.
Biggie Smalls. Ay, Dios santo. I don't really like numbers that much right now. Okay. 57, 186, 100. Hora y media. Hola amigos, ¿qué tal? Ya llevamos una hora y media ahorita de trabajo y vamos bien. Vamos por la segunda hora que ya con eso ya es bueno. Creo que nadie tiene ganas, ¿no? Porque es viernes, pero ya saben, tenemos que ser disciplinados, hacer las cosas aun cuando no tenemos muchas ganas. No tengo ganas, estoy haciendo algo que no me gusta, pero tenemos que aprovechar. Ok, amigos, son aquí son 6:25, regresamos 6:30, o sea, en 5 minutos más. Venga, let's go. Así es, Dani. Hoy quiero saborear mi dolor. No. Compasión ni piedad. Ya no quiero estudiar. Hola amigos, vamos a por la segunda hora. Vamos bien. Venga. Ok, vamos a darle. Ya ponemos la alarma. Ya no recibo. No, así.
So first of all, this is totally consistent with our previous understanding. The point 6 is a distance of 6 from 0 in the number line. The point negative 14 is a distance of positive 14 from 0. And where 0 is at a distance of 0. This new understanding has important implications in algebra. So we'll just be talking about some of the very basics of algebra here for a moment. For example, the absolute value of x is the distance of x from the origin. And again, distance is always positive, so whether we're at positive 50 or negative 50, we're at a distance of 50 from the origin. What if we want the distance from x equals plus 5? Well, of course, the classic operation for finding distance on the number line is subtraction. So we're going to subtract and then take the absolute value of the difference. X minus 5, the absolute value of x minus 5. Of course, this works with numbers, if we think about it, because if we plug in 7, 7 is a distance of 2. Take the absolute value of 7 minus 5, that's absolute value of 2, which is 2. If we go down to x equals 3, that's also a distance of 2 from 5. We plug in x equals 3, we get 3 minus 5, absolute value of negative 2 is, of course, 2. And so in either case, it works. We're getting the distance from 5 on the number line. Now suppose we want the distance from x equals negative 3. Well, the same pattern, we're going to subtract the absolute value of x minus negative 3. But here's the tricky part. When we subtract the negative, we get a positive. And this is what really can confuse people. Why are we adding when it's a negative? Well, really what's happening is we're subtracting a negative. Subtracting a negative winds up as addition. Now notice this formula also works perfectly well. Because if I try a point, say, negative x equals negative 4, well, what's the distance from negative 3 to negative 4? Well, if we plug in negative 4 plus 3, we'll get the absolute value of negative 1, which is 1. And it is a distance of 1. That makes sense. But what happens if we put in positive 4? Well, then we get the absolute value of 4 plus 3, which is 7. Well, what's going on there? Think about the number line. Here is negative 3. Here's 0. Here is positive 4. Well, what's the distance between them? Well, from 4 down to 0 is 4. From 0 down to negative 3 is another 3. So there is, in fact, a distance of 7 between positive 4 and negative 3. And that's what the formula gives us. So the formula actually works. If you're having trouble making sense of why the formula works, try plugging in numbers and thinking about where they are in the number line. Equal terms that's is at a distance of 0.
Mm-hmm.
0, x equals the value. If we go down to if the tricky part, when we subtract a negative, we get a positive. And this is what really can confuse
Absolute value. Okay.
Is equal 0. Here is positive 4. Well, what's the distance between them? Well, from 4 down to 0 is 4. From 0 down to negative 3 is another 3. So there is, in fact, a distance of 7 between positive 4 and negative 3. And that's what the... So now, let's think about one more example of this. The distance of x from positive 2, again, we subtract x minus 2, absolute value of x minus 2. But the distance of x from negative 2, we're going to subtract the negative 2, and the subtraction winds up with it looking like addition. And so again, this is anti-intuitive. People see the switch in sign. How come the positive and negative goes to a negative and positive? Sometimes it really confuses people. What's going on is we're performing subtraction. You subtract a pump. Here's an equation. Pause the video and see if you can solve for this equation. While I'm plugging in numbers in Fick's equation.
Distancia entre...
Okay, so what we're saying is, whatever x is, it is a distance of 4 from the location 1 on the number line. And so we could just find 1 on the number line and then walk a distance of 4 in either direction. And so we walk to the right, we get to x equals 5. If we walk to the left, we get to x equals negative 3. So those are the solutions. The solutions are x equals negative 3 or x equals 5.
Okay.
Here's a practice problem. Pause the video. Think about this.
There we go. Son 62 y 62 y... ¿Cuánto queda? 12.
We'll talk about this. And the distance of 20 plus 25 is negative. And so D equals 50.
Qué verga.
D is the distance between x1 and x2.
Ay, no.
Well, that is just 25 plus 25, which is 50. And so D equals 50.
All right. You take this.
In summary, when we multiply or divide like signs,
We take those.
Order of operations. Some folks might remember this topic as PEMDAS. In this video, we're going to expand the view. The first idea we need to discuss is the idea of a mathematical grouping symbol. Any grouping symbol shows that certain operations are grouped together. What are the mathematical grouping symbols? Well, by far, the most famous is parentheses.
Mm-hmm.
And of course, anything inside parentheses has to happen before the stuff outside parentheses. Parentheses group those operations together. So that's one grouping symbol, but it's not the only one. Another very common one are square brackets or straight brackets. These have the same meaning as parentheses. There's really no difference. It's much more stylistic difference. Some people parentheses instead of brackets. A bunch of things underneath the square root sign. Another one is the long fraction bar. So for example, if I have x plus 6 over x minus 4, that denominator, x minus 4, that's grouped together. That comes as a single unit. I can't, for example, cancel the two x's there, because anything that happens to that denominator has to happen to the whole thing. They are grouped together. So this is another example of a grouping symbol. Another one, and this one doesn't really even have an official name. I'm calling it the exponent slot, for lack of a better term. What I mean by that is all the stuff that would be up in the exponent. So the x minus 7, so this is another denominator, x minus through the square root. That's very important. This is a single unit. I can't, for example, cancel the two x's there, because anything that happens to that denominator has to happen to the whole thing. They are grouped together. So this is another example of a grouping symbol. Another one, and this one doesn't really even have an official name. I'm calling it the exponent slot, for lack of a better term. What I mean by that is all the stuff that would be up in the exponent. So the x minus 7 here, that's up in the exponent. We have 3 to the power of x minus 7. That x minus 7 has to happen together. We have to do that first. Then we can compute the power, and then we can do any operations that are outside of the exponent situation. So the exponent slot is also a grouping symbol. Notice the two meanings of each of these. The long fraction bar means both group and divide. It has those two meanings. The exponent slot means both group and to the power of. It has those two meanings. And of course, all this is perfectly clear when we have things written in proper mathematical formatting. Everything's clear in proper mathematical formatting, but translating plain text is tricky. Well, what do I mean by this? Well, when you write an email or when you post something to a forum, of course, you're writing in plain text. When you're writing in plain text, you don't have full mathematical formatting available. And so this can lead to some problems. Well, here's what I mean. Suppose we have some expressions like this. Suppose we have to type these email or in a forum. We have to type them in plain text. Let's say this first one, for example. Many people will make the mistake of writing it like this. And this is 100% wrong.
Okay.
Now, why is this wrong? So people look at this, they see 2 to the n plus 3, and they say, well, that's 2 to the power of n plus 3. Well, I'm just going to stick in the caret. And of course, the caret does mean 2 to the power of. But the problem is, what exactly does this red expression mean? Does it mean that we're doing 2 to the power of the whole thing, n plus 3? Or is this merely 2 to the n? We're going to calculate that power, and then separately at the end, we're going to add 3. What's actually being grouped together? And the problem here is, as we just said on the last page, the exponent slot has two meanings. It has the meaning of 2 to the power of, but it also has meaning as a grouping symbol.
For example, that would be the same
the meaning of 2 to the power of, but the caret is not a grouping symbol. And therefore, we need to substitute in our own grouping symbol to encapsulate the grouping symbol meaning that was written on the side of the equation. So the correct way to translate this into plain text is like this. We have to supply our own grouping symbol to show how things are grouped. Similarly, we have an expression with a long fraction bar. Many people will make the mistake of writing this like this. And of course, this is an unholy disaster. This is completely because again, we don't know what's in the denominator. We have 1 divided by, and then is it y? Is it y minus 7? Is it y minus 7 plus 3? We have no idea from the way it's written right there. Once again, the long fraction bar has two meanings. That's the meaning divided by, and it also has the meaning of a grouping symbol. The little slash, the inline slash, that carries the meaning of divided by, but that's no longer a grouping symbol. So we need to supply our own grouping symbol once again. So here it is written correctly. So in some ways, this might strike you as an inconvenience. It's sort of an accident of our current technological state that all these things, we're sending lots of messages in plain text. In plain text, we can't do the mathematical formatting. I actually look at it as highly advantageous because when you have to translate mathematically formatted information into plain text, it forces you to think explicitly about the nature of the grouping symbol. If you're thinking explicitly about the nature of the grouping symbol, you're thinking much more deeply mathematically. So I would say even if you don't have to send any emails, even if you don't have to send in any support tickets to the Gucci, if you don't post in the forums, at least practice translating mathematical format information into plain text. Practice this and make sure you understand the grouping symbol because that's something very important mathematically. Okay, now we can talk about order of operations. Many people call this GEMDAS, but I will call it GEMDAS. Why am I calling it this? Because that first rank, that first priority, that's not just parentheses, that's all grouping symbols. All grouping symbols have the same level of priority in their grouping, in the grouping function. The grouping symbols come first, then exponent, then multiplication, division, then addition and subtract. 7 minus 5, we get 2. Then we have to do the exponent, so now we just have a single number to it. And then we divide. We could do this. We could do A divided by B. Separately, we could do B divided by C, and then just multiply the two quotients. Or we could do this. We could do A divided by C, multiply by B, and then divide by D. So I hope by showing these different orders, I'm giving you a sense of the different. Ways that you can rearrange things. As long as you're always multiplying by the same things and dividing by the same things, as long as those two don't get swapped, you can swap around the order in any way that you want. And given that you can change the order in any way you want, is there any particular goal you should have? Well, yes. Always choose to cancel before you multiply. This is something we're going to talk about in considerable depth. Talk about fractions in the upcoming video. Finally, if there are multiple layers of parentheses or grouping symbols, we have to work our way from the inside out. So in other words, we take the innermost grouping symbol, and then at that innermost level, we do exponents, then multiplication and division, then addition and subtraction. Then we move outside to the next layer, and we keep on moving out and repeating all the GEMDAS priorities, all of them, at each level of grouping. So for example, here I have a long fraction bar. So we have to handle everything under the long fraction bar before we do anything else. Within the long fraction bar, we have parentheses. So that's another grouping symbol. So first thing I have to do is those innermost parentheses, 13 minus 11. That becomes 2. Now, still undefinite. Then we talked about grouping, which I call again. Intro to decimals. In this video, we will talk about decimals, place value, and arithmetic of decimals. So let me say at the outset, this is something relatively easy for you. You're very comfortable already with adding, subtracting, multiplying, 256, what that means, we have 200, 5 10s, and 6 1s. Those are the place values. So we could write this number in the form 256 equals 2 times 100 plus 5 times 10 plus 6 times 1. That's expanding it in terms of its place value.
Mm-hmm.
Notice that as we move a digit to the left, the place value is multiplied by 10. And as we move a digit to the right, the place value is divided by 10.
Yeah.
So for example, the place value gets multiplied by 10. Similarly, if we move to the right, from the 8th, the 10th place, the 6 is in the 100th place, the 2 is in the 1000th place, and the 5 is in the 10,000th place. We could write this number as follows. We could write it as 3 times 10 plus 9 times 1 plus 0 times 1 10 plus 6 times 100 plus 2 times 1,000 plus 5 times 1/10,000. So this is the expanded form in terms of place value. The decimal places to the right of the decimal point represent negative powers of 10. So 0.1 is 10 seconds.
Bueno, la razón por la que los antipsicóticos te dan extrapiramidalismo es porque la inactiva ahora ya no se puede apagar.
100th into the -2, 0.001 is 10 to the -3, 0.0001 is 10 to the -4, and so forth. You can extend this pattern. What can be a little confusing about this? There are a few things that are a little confusing. First of all, notice the 0 to the left of the decimal point. That's purely decorative. I put that in for clarity. That has no mathematical meaning. All that matters here are the numbers to the right of the decimal point. Now, some people get confused because how many zeros should these things have? Well, if we look at 100, for example, 100, 2, 10 to the positive 2, that's 1 followed by 2 zeros. That's very clear. People recognize 100. So then when we go to 100, notice that that's something that only has 1 zero. It's 0.01. It only has 1 zero. That really confuses me. But notice that 0.01, that's 2 decimal places. This is very important. If we look at a positive power of 10 and count the number of zeros, that number of zeros will be the same as the number of decimal places in the corresponding negative power of 10. So again, say the number 10,000, the number
1, 1. Hola amigos, hola, ¿cómo están? Ojalá muy bien. Yo no tanto. Hoy no tomé mi siesta de la tarde, por eso creo que estoy más cansado de lo normal. Pero ya llevamos 2 horas. Somos un grupo chiquito, creo que somos un buen grupo efectivo. Somos 11 personas. Está bien, somos los hustlers, porque normalmente la gente no quiere estudiar los viernes. Yo no quiero estudiar los viernes, pero aquí estamos porque tenemos que estudiar los viernes, ¿no? A ver qué estaban mencionando. Daniela Pérez con todo, así es. Edson Martínez menciona, también estoy estudiando, pero en mi caso es mi primer examen de anatomía. Muy duro. Tú puedes. Mucho éxito, Edson. Y Mérida Amaya menciona, estoy estudiando para nefrología. Muy cool, me gusta mucho esa materia. Creo que es de las más divertidas que me topé en la carrera. Ok, amigos, van 2 horas muy buenas. Creo que le hemos sacado bastante provecho. Vamos a seguir hasta las 3:30. Yo voy a estudiar 1 hora más de lo que tengo que estudiar y media hora de cosas recreativas porque no me gusta mucho matemáticas. Estoy estudiándola porque tengo que hacerlo, no porque me guste. No es mi pasión en la vida. Pero sí, así como dice Kate Navia, se sacrifica los viernes. Pero sí, esto es un sacrificio relativo. Más bien, invertimos el tiempo en un viernes para poder tener libre el fin de semana. Yo por eso prefiero trabajar los viernes, aunque esté más cansado. Está estudiando electrocardiograma por una ponencia súper. Fíjate que yo tengo aquí, por aquí debería tener un video de electrocardiograma normal, chance y te sirva. Eh, pero sí, vamos bien, amigos. Vamos a descansar 4 minutitos y seguimos. Los quiero. Venga. No sé nada. Gracias, ya. Oh boy, oh boy, oh boy. Uy, ¿cuánta pila tienes, güey? Ok.
Ya lo puedes quitar ahorita, no.
Tengo 21 de todas maneras. Hola, amigos, ¿cómo están? ¿Como yo, hartos? ¡Let's go! Vamos bien, amigos. Vamos por las 2:30 ya. O sea, ya con 2 horas creo que estuvo bien por ser viernes sin cuarentena. Vamos a seguir hasta las 3:30 porque es como un reto personal que nos tenemos que poner diario. Así que vamos a darle, amigos. Miren, éramos 20, quedamos 9. Nomás quiero que se den cuenta de eso. Vamos a hacerlo.
Suben.
Normalmente siempre suben, eso es cierto, ¿eh? Normalmente siempre terminan siendo 30, algo así. Pero somos 9, nadie quiere estudiar hoy. Así que ustedes 9 que están aquí son luchones y ustedes pueden, ¿ok? Exitosos. Let's fucking go. Vamos a darle, ¿ok? Acá en realidad son 2, 8. Después de mi speech motivacional quedaron uno menos.
No quieres ser exitoso.
No pasa nada. Ahorita estamos descansando un poquito más porque pues la hora. Ok, vamos a ver.
Voy con calma.
Adiós. Have fun, man.
Miren, nerd. Sí, esperen.
Ok, Diego también nos acaba de abandonar. Entonces, uno menos. Solo quedamos 7 aquí.
¿Quién era Diego? Ay, por semanas. Oye, chicos, ¿no hay un lugar mejor?
Morena, eran tus ojos, qué lindo. En tus ojos quisiera llevarte al mar y nunca regresar. I say, oh my God. Y empezó a pegar el café. Let's go, 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 let's go. Llevarte al mar.
The right of any non-zero digits are meaningful for that has
Este es 1/10. Thousand. O sea, 1/10,000. That's a whole fucking lot. O sea, 10 a la menos 4.
right of any non-zero digits are meaningful for decimal places or places. If I tack on extra zeros to the right, those are completely unique. They mean absolutely nothing.
Like me.
Now you may have this dim memory from science class that there was something called significant figures. Sometimes zeros mattered, sometimes they didn't. We're not going to worry about that. Significant figures are not on the test. The way that they use numbers in science is not the way that they use on the test. So on the test, these zeros are completely unique. Now we can take a look at arithmetic with decimals. Adding and subtracting decimals is quite straightforward. Simply line up the decimal points and add or subtract vertically. Suppose we have to add these two decimals.
I'm okay being alone.
Up vertically. The decimal places are lined up. Once they're lined up, then we just add. Similarly, if we have to subtract two numbers, we're going to line them up. The decimal places are lined up together. Now that they're lined up,
Can I take this?
For multiplication, step 1 is to put the number of digits to the right of the decimal point. So suppose we're going to multiply these two numbers. One, we have to count the number of digits. The first factor has 2 decimal places. The second one has 3 decimal places. Now we add those. 2 plus 3 is 5. The product will have 5 decimal places.
A lot of
Now
different.
we know how many decimal places the product will have. Now we can ignore the decimal point entirely. Find the product of the positive. 625 times 48. What is this product? Well, how do we find this without a calculator? Turns out there's an amazing trick that we'll talk about in a later video. This is called the doubling and halving trick. It turns out when you're multiplying two numbers, of course, one thing that's always allowed, you could multiply one of them by 2.
Sería doble. 250. 4.
And divide the other by 2. That's one thing that's always allowed. It turns out that it's very
2500. Vamos.
advantageous to do this if one of the numbers is even and the other number is a multiple of 5. Turns out that it's very advantageous to do this. So what I'm going to do, I'm going to divide 48 by 2. That's going to be 24. I'm going to multiply 625 by 2. 25 times 2 is 1250. So I change that to 1250 times 24. That is a 50 in it. So I'm going to multiply that by 2 again. So divide 24 by 2, I get 12. Double 1250, I get 2500. Well, that also has a 500 in it, so it makes sense to do this again. I'm going to double 2500 and half 12. That's 12 is 6. And 2500 doubled is 5000. Well, now I've got it to one where it's very easy to multiply in my head. 5000 times 6, that's 30,000. So this is a very handy trick to keep in mind. Now we know we need 5 decimal places. We found that out in the original problem. So we put the 5 rightmost decimals of this product to the right of the decimal. Notice that this product only has 5 decimal places. It only has 5 places, so all of them are going to get put to the right of the decimal. So when we multiply 6.25 times 0.048, we get point and then write 3 and then 0. Of course, all those zeros don't matter. We can just write this as 0.33 tenths. Notice that to find a power, that's a special case. Suppose we have to do well, this is 0.03 times 0.03 times 0.03. Notice what we have here, that's 2 plus 2 plus 2, 6 decimal places. The product will have 6 places to the right of the decimal point. So we know that even before we go up the line. Now just consider the number itself, 3 cubed is 27, so that last 7 must land 6 places to the right of the decimal point. It must land at the 1 millionth place. So 0.03 cubed is 0.00027. That 7 is 6 places to the right of the decimal
There you go. What the fuck just happened?
So 0.03Q is 0.00027. That 7 is 6 places to the right of it.
No. So that right most. Okay, entiendo. I get it.
Decimal point. This is 27 billions. Now division of decimals. To start, simply move the decimals of both numbers one place to the right and continue until the denominator divisor is a whole number. When we move the decimal one place to the right, say 2.45 to 24.5, we are multiplying the number by 10. Since we multiply both the numerator and the denominator by 10, the value of the quotient remains unchanged. Essentially what we're doing is we're multiplying by 10 over 10, which is 1. So for example, suppose we start with this. Well, we can start sliding that decimal point to the right. Slide to the right once, slide to the right again. At this point, the numerator is now an integer, but it's really the denominator that matters. So we have to keep sliding to the right. What this does is adds zeros at the end of the number to the numerator. Finally, we get that number in the denominator down to an integer. Now we have 5,600 divided by 7. Well, that's easy to do. That's just 800. So now, let's look at another example. Suppose we're dividing these two decimals. Again, start sliding to the right.
Sería 3. Es 25.1325. 2500.
The right 1 point. Well, now notice we could keep on sliding to the right, but notice 0.25, that's a quarter. So notice that a very easy way to cancel that would just be to multiply the numerator and the denominator by 4. We multiply by 4. In the denominator, a quarter times 4, that's just 1. So we multiply the numerator by 4 because we get something over 1, so it just equals 0.0052. So 52 10,000ths. In summary, we talked about place values and decimals. We talked about how to subtract, add and subtract.
Okay, understand this sort of, not really. Still.
Again, we will discuss a couple ideas that may initially not seem to be related to the idea of rounding, that will be important for that discussion. We need to consider the nature of decimals of the number. The first question, how many numbers are between 3 and 4? On the number line, how many numbers are between 3 and 4? Of course, there are no integers between 3 and 4. That's not the question. I'm not asking about integers. I'm asking about numbers in general. There are decimals between 3 and 4. How many of them? Of course, the answer is infinite.
Yeah.
There's an infinite number of decimals between any two integers. That's mind-blowing fact number 1. Second question, how many numbers are between 3.99? Again, the answer is infinite. Then the next question, now we're getting a bit ridiculous here. How many numbers are between 3 and a whole bunch of 9s after it? Like there are 20 9s after it. That number is 4. How many decimals are in that tiny infinitesimal little gap? Well, nature of decimals, the nature of the number. This first fact will not be tested directly on the GRE, but knowing this will give you important perspective in the discussion of rounding. Now we talk about rounding. Let's start very easy. Suppose we're rounding to the nearest integer, and suppose there is only one digit to the right of the decimal. The rule is very easy. If the number in the tens place is 0 to 4, then we round down. If the number in the tens place is 5 to 9, then we round up. Very straightforward.
Yeah.
So here, we'll select those numbers while they're in the first category, the 0 to 4 category. Those all get rounded down. Now the other ones are in the 5 through 9 category. They all have digits in the tens place that are 5 through 9. And of course, those ones get rounded up. So far, so good. Now we have a twist. We are still rounding to the nearest integer, but now we could have any number of decimals to the right of the decimal. Here's the tricky part. We look only at the number in the tens place and no other number. The number in the tens place is 0 to 4, we round down. The number in the tens place is 5 to 9, we round up. The subsequent decimals, anything beyond the tens place, is absolutely irrelevant. Here's what I mean by that. So of course, most people are pretty clear of the fact that numbers like 7.12 or 7.384, those get rounded down. And of course, 7.96 or 7.532, those get rounded up to 8. Most people get that. But where it gets tricky is when we have a 4 in the tens place with 4 digits behind it. So for example, 7.45, that has a 4 in the tens place. That gets rounded down to 7. 7.49 gets rounded down to 7. 7.49999 gets rounded down to 7. Now this starts confusing because people think, come up to the 4 get round up to 5, and now the 5 has to round up to 6 and 7. And so what we've done is we've done rounding in 2 steps. We've now rounded up. And here are the answers.
Hundreds, please.
In this video, we discussed the rules of rounding and covered the mistake of double rounding. In this lesson, we will talk about ways to multiply. Divide by 10 quickly. Also to multiply and divide by powers. Now for some people, everything in this video is going to be reviewed. You don't have to watch the video of that. But if you're at all rusty with these skills, these are really important skills to know. For example, 10,000 is a little trickier. The number of factors of 10 in the denominator equals the number of places that has 2 decimal places to the right of it.
Okay, I need to write that down. 0.01 es igual a 10 a la menos 2. Es igual a 1 entre 10 por 10.
The decimal point, so that's 10 to the negative 2, 1 over that's 10. 0.0001, that is 1/10,000. That has 4 decimal places less than the negative 4, or 1 over 4 factors 10. Of course, in any number,
Son 3, ¿no?
each place value 1, that is
0.01 es igual a 10 a la menos 4. No. Chingado. Estas son 4 ceros. Menos 4. Menos 10,000. 10,000. Ceros.
(1/10,000) that has 4 decimal places less than the negative 4, or 1 over 4 factors 10. Of course, in any number, each place value is 10 times more than the one to the right and 10 times less than the one to the left. This is a huge idea. This is a very important idea. It actually underlies everything in this video. This leads to a very quick trick. When multiplying or dividing a number, but go 24 times 10, that decimal place right now is next to the 4 and moves 1 place to the right, so we have to stick in a place holding 0. One way to think about this, have to remember, multiplying by 2, we move the decimal point 1 place to the right, holding 0. When I multiply by 10, the place to the right, so I wind up with 2 place holding 0.
Ok, amigos, somos pocos pero locos. Vamos bien, llevamos ya 2 horas y media, ya vamos por la tercera hora. Creo que no se me ha pasado rápido. Fíjense que hoy es de esos días que de verdad no tengo ganas de estudiar, pero qué bueno que hacemos esto, ¿no? Creo que poco a poco lo vamos armando, es importante ser disciplinado, recuerden esforzarse entre semana para que el fin de semana descanse. Y vamos bien, vamos por la tercera hora ahorita, en 5 minutos. No, tampoco tengo ganas de estudiar, pero tenemos que hacerlo porque tenemos que poner orgullosos a los nuestros. Libros de farmacología que recomiendo. Te voy a decir los que recomiendo, Edna. El Goodman y Gilman me encanta. Y Gilman. Qué bueno, Alejandra, que te ha servido. Me gusta Goodman y Gilman, me gusta también el Rangel. El Rangel me gusta como generalidades, fíjate, como una introducción es excelente libro. Y hay unas notas muy buenas que se llaman Pharmacology, Kaplan Notes, muy buenas, me encantan. Ese era mi libro de apuntes en realidad. Y hay otro que es de la serie de RT, que es para preguntas. Yo hago ya sea preguntas en el RT de farmacología, y la verdad no me acuerdo el autor, sorry. Descansemos, tenemos 4 minutos. Let's get it. Venga. Mamá, no tengo ganas de estudiar. Qué mal, ¿no?
Vamos a ver quién se fue un poquito.
Ajá. Somebody help me. Can't do this anymore. Auxilio. No, no es una buena idea estudiar los viernes, ¿no? Pero ¿saben qué? El problema de esto es que la gente, si hubieran inventado las semanas como, ¿sabes qué? Una semana va de lunes a jueves, esto ya contaría como un día de descanso, definitivamente. Pero no, no pasa. Ok. Bueno, amigos, vamos entonces a seguir. Nos falta poquito. Vamos por la tercera hora. Ya muy buena, muy buena. Ya con esta última ya terminaríamos nuestra sesión, pero le vamos a seguir hasta las 8:30 cómodo. Ahora sí, ya me cansé mucho. Bueno, sigamos, amigos. Voy a poner la alarma otra vez. Ya no hay muchos, quedamos 11 de todos los que estábamos. Tal vez podría terminar aquí el video, tal vez no, pero lo vamos a seguir. ¿Por qué no? Hasta las 8:30. Let's get it. Let's go. Let's go.
places, so that's 10 to the negative 4th, or 1 over 4 factors of 10. Of course, in any number, each place value is 10 times more than the one to the right and 10 times less than the one to the left. This is a huge idea. This is a very important idea. It actually underlies everything in this video. This leads to a very quick trick when multiplying or dividing a number by some power of 10. First of all, when we multiply any number by 10, just plain, ordinary, regular 10, we move the decimal point 1 place to the right. So 24 times 10, that decimal place 3 tends to be the 5 and the 0.0 place. Or move 1 place to the left of point, holding zeros when I multiply the power of 10 is 10 to the 2. 0.01 put in the 2. So the 3, and we move to the 10. When I divide by negative 2, 37.4 place 1. Next to that last boost to the left. Notice that now by 100, that's the same as multiplying by 100. And then I just multiply. The ordinary rule. If I divide by 10 to the negative 4th, that's the same as multiplying by 10 to the positive 4th. And I follow the ordinary rule.
Gracias.
One common mistake in these problems is people sometimes get confused on which way to move the decimal point. 10 to the negative 4th, that's the same as multiplying by 10 to the positive 4th. And I follow the ordinary rule. One common mistake in these problems is people sometimes get confused on which way to move the decimal point. Always think about whether this multiplication or division will make the number bigger or smaller. Make sure that your answer is bigger or smaller, as it should be. One thing that can be very helpful for building intuition on this, if this is something unfamiliar to you, just sit down with a calculator, type in a number, and then multiply it by some power of 10, or divide it by some power of 10, and see if you can predict where the decimal place will wind up before you hit enter. Very good to practice this with a calculator to help you build intuition. Eventually, your predictions will get so good that you won't need to do it on the calculator at all. In this video, we learned how to multiply or divide numbers by powers of 10 simply by sliding the decimal point one way or the other.
Okay, we got it. We got it.
Intro to fractions. I realize that fractions are not necessarily everyone's favorite topic. I hope to convince you during the course of the rest of it. number line with a few fractions. Of course, most of the fractions fall between the integers. Notice that fractions can be positive or negative. Also, there are an infinite number of fractions between any two integers. Between, say, 1 and 2, there's an infinity of fractions. We won't spend a lot of time on this idea, but it's just an important perspective to have on some of the things the test will do in front of the 1. So negative 1 divided by 5, we could also write 1 divided by negative 5. So all three of those are perfectly equivalent and interchangeable. So the test will actually expect you to have that fluency. Negative sign has to sit in one place and can't move. Well, no. All three of these are equivalent. You're free to move that negative sign around. So the test will actually expect you to have that fluency. So let's talk about some terms. Suppose we have the fraction 3 over 16. What do we call the place where the 3 is sitting and where the 16 is sitting?
Numerator and denominator.
The top part, the upstairs of a fraction, is the numerator. This fraction has a numerator of 3. The bottom part, the downstairs of the fraction, is the denominator. This fraction has a denominator of 16. Two ways of thinking about a fraction. Well, first of all, we can think of it as division. 2 sevens means 2 is divided by 7, so there's an actual arrow. So notice that, and if every time you 35 over 5, it's useful to think about the fraction as division because that division we can actually perform. 35 divided by 5 equals 7. Notice that 35 over 5, that in every way is an equivalent way to write the number 7. When we write 35 over 5, we are writing the number 7 in kind of a hidden form. 15. What's going on here? We can, if we as products, 2 times 5 over 3 times 5. In other words, the numerator and the denominator of the original fraction both got multiplied by the same fact case. We could multiply, as we did before, this would give us 12 over 32, an equivalent fraction. Essentially, we are multiplying the fraction by 4 over 4, which equals 1.
Yeah.
As we can multiply both numerator and denominator by the same factor, we can also factor out the same positive integer from both the numerator and the denominator. So for example, suppose we have 6 over 42. Well, we can express both of those as products. 6 times 1 over 6 times 7, and then we can factor out those 6 and cancel them and get down to 1/7. The 6's cancel. Notice that canceling is a form.
Okay.
Form of division. That's very important. Canceling is a form of division. Some folks have misconceptions about canceling. Canceling the common number in the numerator and denominator does not merely quote, go away. A lot of people have this sloppy way of talking about it. The 6's go away. That's not a very healthy way to think about this. It leads to mistakes. For example, suppose we had 8 over 40. We wanted to simplify it. Well, clearly, we can divide it. We can cancel the 8.
Sí, podría ser 8. Entonces, 8 por 5. Te quedan
start out with 72 over 96. Both of those are divisible by 6. We can divide down to 12 over 16. Both of those are divisible by 4. We can divide down to 3 over 4. We cannot divide any further. That fraction is in lowest terms. Once the fraction is in lowest terms, we cannot simplify any further. Lowest terms is also known as simplest form. Make a habit of always, always, always writing all your fractions in simplest form. Well, why? First of all, it will make all your calculations much easier because you'll be dealing with smaller numbers. On the GRE multiple choice, the answer choice listed will almost always be in simplest form. Practice simplifying though, because simplifying along the way may make you hear the answers. Will be helpful. Practice writing these fractions.
Sería 32. 6, 24, 28, 2, 2, 3, ya no. 45, 54, 35, no queda nada. Olivia, goed man, wat is het doet?
The lowest terms. Pause the video. Here, and then we'll talk about these. Okay, here are the answers.
¿Qué?
The last topic for the practice writing these fractions in lowest terms. Pause the video here, and then we'll talk about these.
Qué bien soy. Ay,
Okay.
Sí,
Here are the answers.
4.
estamos a 4.
The last big fraction topic for this video is how to handle fractions that are greater than 1. We have a fraction greater than 1. We have a choice about its form. We can write the fraction as either an improper fraction, that is to say, part integer and part fraction, equal sign between them. Notice when it makes numerals written correctly, the fraction part is always a fraction less than 1. Any part greater than 1 is put into the integer. mixed numeral pool. You can use mixed numeral.
Okay, the next.
Conversions between fractions and decimals. Fractions form a group that mathematicians call the rational numbers. Rational because they are ratios. We write a fraction, a rational number, as decimal. One of two things happens. It either terminates or repeats. Well, those are fancy words. What does that mean? Fractions that form terminating decimals. The word terminating simply means coming to an end. So very simply, if we write 1/4 as a decimal, it's 0.25. After two places, the decimal just comes to an end. There's no more decimal after that. There are just two decimal places. That's it. That's a terminating decimal. Another example, 3/8. That's 0.375. So that's also a terminating decimal. It's a decimal that just comes to an end. That's not an approximation. That's the whole thing right there. So these are terminating decimals. If it doesn't terminate, if it goes on forever, then it repeats. Fractions that were repeating decimals. So for example, with 1/3, that's just 0.333 repeating. So it's the same digit repeating over and over again. Technically, to write it correctly, we'd have to write an infinite number of threes. That would be convenient. Instead, we write it with a bar over the last three, and that bar just means continue to repeat this decimal forever. Similarly, 1/7, this is not a single digit repeating, this is a set of.
Hola amigos de viernes. Nos quedan solo un último set para completar las 3 horas y media. Lo hicimos excelentemente bien, ya estoy muy cansado. pero vamos a hacerlo un último. Creo que no dormí bien anoche, más bien ha de haber sido eso. Pero, ok, felicidades a los 9 que siguen aquí. Bueno, 10, ya somos 10. No sé si esto me cuenta a mí, creo que si me cuenta a mí somos 10, si no, somos 11. Pero bueno, hay que darle. Descansemos 5 minutos, amigos. Voy a tirarme al sofá un poquito. Tengo un grupito de estudio. Almighty push. Uf. Venga. Ok. Hola amigos. Ya lo quedamos 8. Venga. Sí, Gage pregunta, ¿no les pasa que el tiempo se va volando? Claro que se va volando cuando uno se divierte. Sí, la noche se pasa muy rápido, sí, sí, sí. Y sí, fíjate, yo leo un par de páginas y se me pasa rapidísimo. Yo, por ejemplo, ahorita ya solo quedamos 7, no sé dónde fueron. este, Sale, mi mamá también ya se fue, vino a leer un rato y ya se despilfarró. Yo voy a mi última media hora, la voy, como ya estoy harto, también ya me cansé, y yo a veces cambio de materias como para no hartarme tanto. Ahorita voy a estudiar, bueno, es aprender un libro sobre conciencia, pero les recomiendo también lo mismo, ¿no? Si se cansan, pueden alternar entre materias o algo así. Yo, pues ahorita no tengo materias más que mi examen que les digo, pero voy a hacer esto, así que hay que divertirnos la última media hora. Let's fucking go. Estoy listo para tantas cosas. Y ahora sí voy a poner un poquito de música clásica porque ya me cansé. Y ocupo concentrarme. Perception, memory streams. Nice. Or circuits. Separate sensory right. Sí. Mm. Okay. Ujú. Entonces, usually for another information stuff, just have to create something. Wow. The various medial temporal is strongly connected with familiar performance of various medial temporal areas to the prefrontal cortex with the semantic stream. Super fucking strong, man.
chemical area of the facade extreme connects to the interior cerebral cortex. Hippocampus to the ventromedial area. Okay. Fucking careful. Okay. Communication, where semantic memories are stored. Semantic and spatial complex semantic memories are stored in language processing unit stores semantic labels. Attention screen, which is viewed as an important semantic conceptual hub. Okay. It integrates classifiers, inputs, sequence, Okay. 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 It's fucking big. It does so by analyzing similarities between individual items to form generalizations and temporal core is one of the brain's areas first affected in Alzheimer's and accounts for some of the early memory problems.
Okay, that's fucking huge. To humans. Conmigo acordo com uma semantic concept areas of the prefrontal cortex, these connections to the body. Okay, brother. I need to see that. Show me the way. Wow. Okay. With complex perceptual representations with complex perceptual representation. When episodic memories become semanticized, they lose their dependence on the medial temporal lobe and becomes the more cortically based. Okay? Okay. I think you get it. Situations okay, that's what you want for stuff, right? Jane, comment person. The greater involvement of the cortex, all the memory, hippocampus and the protection, they suggest that the hippocampus is is water to learn rapidly, which is especially important for young mammals that found unique effects throughout the so the opinion information which is particularly information cleanses your skin. That copies of the memory come to be stored elsewhere in the process of learning the categories. These don't have a complete presentation but support memory training. These don't have a complete support memory training. Okay. What do we get in the presentation here? ¿Quién? ¿Cómo van? Okay, that makes sense. Yo. Self-reflection. Yo decidí, yo escogí, yo dije. Ok, no puse alarma, pero amigos, we've made it. A ver. Ok, ya no sé a quién más lo estoy hablando, ya quedan, se sumaron 2 personas a esta didáctica. Pues les agradezco a todos los que se quedaron, ya sé que hacer 3 horas y media en fin de semana, en viernes, en cuarentena particularmente, es muy complicado. Como les comentaba en otros videos, no me gusta estudiar en casa, la verdad yo batallo mucho, prefiero en un café o en la biblioteca, en mi casa batallo muchísimo, pero sin duda esto me ayuda, ¿no? Entonces, a ver qué comenta Mauricio. Tercer diciendo con Pavel, sigue siendo difícil, pero así es. 2 semanas vamos a hacerle. Yo estoy seguro que después de las 2 semanas esto ya se va a hacer un hábito y con mucho gusto. Y fíjense, todos los días he estudiado, pero no me había tocado como grabarlo, o sea, entonces pues, nunca le vi sentido, pero sí me gusta, fíjense, me gusta que nos acompañemos, aunque somos pocos, ¿no? Pero qué bueno. Pues les agradezco otra vez por haberse quedado. Nos vemos, yo creo que el lunes. Mañana voy a trabajar en un par de cosas, pero no voy a estudiar. Entonces, como nomás voy a teclear cosas, pues no voy a transmitirlo. Pero nos vemos como no el lunes a la misma hora. Ahorita voy a seguir trabajando, pero en un par de cosas que son de teclear, ya no es de trabajo mental. Bueno, sí, poquito, ¿no? Pero sí, hay que seguirle dando. Un gustazo, amigos, verlos otra vez. nos seguimos reuniendo, seguimos trabajando y pues de aquí hasta, y esto tiene que ser un hábito, ¿no? Porque tenemos que agarrar esta nueva normalidad y aprender que así tenemos que estudiar un rato, ¿no? Por lo menos hasta que haya una vacuna. Pero estoy muy orgulloso de lo que hicimos. Ya vi que ya se están desconectando algunos, pero les quería agradecer ahorita los que están. Pues cuídense mucho, niños, les agradezco mucho. Nos vemos hasta el lunes. Estudien, le echan ganas, repasan, trabajan y demás cosas. ¿Sale? Los quiero. Bye. Gracias.